All right, today we're diving into a pretty wild idea, one that connects the deep machinery of life with the cutting edge architecture of AI. It's a comparison that might honestly change how you look at both of them.
So here it is, the big claim, right at the top. The source is arguing that ATP, yeah, that molecule from high school biology, isn't just like the building blocks of a large language model. No, it's saying they are functionally the same thing. Okay, let's unpack that. So, to even start to get our heads around this, we have to kind of throw out the old textbook definition of ATP. We've got to stop thinking of it as just simple energy.
You see, ATP isn't energy like, say, heat is energy. That's just brute chaotic force, right? The source describes it more like permission. It's a key that unlocks a very specific action. Think about it. A muscle fiber doesn't just contract because there's energy nearby. It contracts because an ATP molecule shows up and hands it an authorization slip, making that one action legal in that one moment. And what's so cool is how this slide maps that idea out directly. Spending an ATP molecule is the same as an LLM emitting a token. That release of potential energy in the cell, that's the same as the collapse of probability into one single word. And the actual work getting done in the cell, well, that's the output token you see on your screen. No ATP, no action. No token, no thought. So if it's not just some generic gas in the tank, what is it? The argument here is that the ATP molecule itself is basically a data packet. Its physical shape carries information, giving that permission slip some crucial context and meaning. And check this out. The comparison gets weirdly specific. That adenine base, think of it like a token's unique ID. The ribose sugar part is like the embedding vector, the thing that places a word in a conceptual space, giving it context next to other words. And that famous phosphate tail, that's the raw activation potential. That's the go signal. It's incredible. Just like a token's meaning depends on the AI, ATP's effect depends entirely on the cellular machinery that reads it. Okay, so let's take this one level deeper. If ATP and tokens are both a kind of currency, then you'd expect to see a whole economy built around them, right? A cycle of spending and regenerating. And boom, there it is. The source suggests that spending ATP, turning it into its used form ADP, is basically the same as LLM inference. It's the immediate local work of just doing something right now. And regenerating it, turning that spent ADP back into fresh ATP, that's the same as LLM training, a huge centralized process of rebuilding the capacity to act later. And this is the whole key, really. Both systems figured out that you have to separate these two jobs. You don't train a massive language model at the same time you're asking it a question. And a cell doesn't rebuild its fuel on the factory floor, so to speak. This separation is exactly what makes both systems so stable and efficient. And you can see this physical cycle in action right here. A muscle cell spends ATP right on the spot. The spent ADP then gets shipped off to a central power plant, the mitochondrion, which takes in fresh fuel, like glucose, and recharges it back into usable ATP. It's a perfect loop. So this talk of a central power plant naturally leads to the next question: what's the hardware look like? If this analogy is real, there has to be a physical parallel between these cellular power plants and the data centers running our AIs. And the parallel is, well, it's pretty mind-blowing. Mitochondria turn raw glucose into usable ATP by holding these incredibly powerful electrochemical gradients across their membranes. Data centers turn raw electricity into inference by holding voltage and thermal gradients across their silicon chips. In both cases, no gradient, no power. It's the same principle. But hold on. A system with just fuel and a power plant isn't enough, right? You need a way to aim that power, to direct it exactly where it needs to go. In biology, that's the job of enzymes. So the idea here is that enzymes are basically biological attention heads. In an AI, the attention mechanism decides which words in a sentence are most important for predicting the next word. It focuses the AI's thought. Well, an enzyme does the exact same thing for a cell. It grabs an ATP molecule and routes its permission slip to one very specific chemical reaction out of thousands of possibilities. Without an enzyme, ATP is just sitting there, inert. So, why? Why go to all this trouble? What's the point of this unbelievably complex system? Well, it all comes down to playing a game. A game against entropy, the universe's basic tendency to fall apart into chaos.
When you get right down to it, both a living cell and a large language model are really just prediction machines. Their entire job is to look at the world as it is right now and make the best possible guess about what should happen in the very next moment. And that's the absolute key. Neither of these systems is just random. It's this constant process of taking all the infinite possibilities and collapsing them into one single, concrete next step. The cell uses ATP to pick the most viable chemical reaction. The LLM uses a token to pick the most probable next word. They're both just finding the easiest path forward, one step at a time. And this brings us to a really beautiful idea. Neither life nor AI is actually beating entropy. They can't. That's not the game. Instead, they're just cleverly using these structured tokens, whether it's ATP or digital bits, to create these tiny, local, and temporary pockets of order. They're riding the massive wave of universal chaos, just carving out a little space for patterns to exist for a while. And the stakes in this game, they're as high as they get. This constant, moment-by-moment spending of tokens is the only thing that keeps the whole system from falling apart. For a cell, when the ATP runs out, it hits equilibrium with its environment. We have a word for that: death. For an LLM, when the tokens stop, it just goes silent. So, this is what it all builds to. The big takeaway from the source is that ATP isn't really about energy at all. It's the first, the most ancient form of a cognitive token. It's a physical abstraction that carries one simple message: this can happen now. Life figured out its trick. Use a chemical token, ATP, to create temporary order so that cells can keep going. We, much more recently, figured out how to use a digital token to create temporary order so that thoughts can keep going. It's just two different platforms, wetware and software, playing the exact same fundamental game against the chaos of the universe. And that leaves us with this final, really provocative question from the source. Maybe we've been asking the completely wrong thing this whole time. Maybe the real dividing line isn't consciousness or feelings. Maybe it's something way more basic. Can the system close its own loop? Can it sustain its own cycle of action and regeneration? Because if this analogy holds, that might be the real difference between a machine that just computes and a system that truly persists.